let's look at a case where the answer could be possibly two answers. So here's our situation. I want you to try to draw this on your own. If you want to cheat and look at page 488, you can in your text, but I challenge you to try to draw this picture just with the verbiage that's here. And you're gonna see me do it too, but I want you to pause the video, read through this, see if you can set it up similar to what I would set up. Okay, pause video, go for it. All right, hopefully you took the time to make this drawing, but we got triangle ABC with very specific information. They're telling us that we have angle A. I'm going to go ahead and make this one going to be angle A, and we'll kind of draw it to scale here. So try to draw like what would be about a 30-degree angle. And so 30 degrees, I don't know, maybe you can do that without a whole lot of thinking, but it's an acute angle. That looks almost 45, but we're going to call it 30 degrees. That's good enough. And then they're telling us that we've got its side, opposite side being BC. So side BC being this, let's put this one over here as BC. And so this would be, there's B, and here is C. And so we know the side opposite of this angle 30 is 7 centimeters. And if we go back up here, let's read it again. And it says that AB is 10 centimeters. So we're pretty close to what maybe would be close to scale here. Stop and think about that. Now, the reason why this brings about an ambiguous case is because technically, if you were to think about this, if you put this angle and draw the triangle so that it's like we swung this over. So think about angle, or excuse me, side BC swinging over within this triangle. You could also have the same measurements where this is 7 centimeters and this is still 10 and angle A is still 30. And so what creates this problem? Well, it's all about when you have an acute angle within your triangle that is opposite the smaller of the two sides. This creates an ambiguous case. It creates a situation where you could have angle C that's looking like that, or angle C. And so actually, like they put in the book, this would be like case 1 and case 2, where your angle is bigger. If you swing it out, it's going to be smaller. And so this is pretty conceptual. So you taking the time to going through in this and drawing this, it's an important part of it, because then you can kind of see what's happening. All right, so what does this mean? It just means that when you have problems that show up like this, you have to be aware there could be two possible answers for, let's say they want to know, well, what's the length or what's the angle measure of angle C? So let's look at this. We'll just continue with this example. So based on the law of sine, we can say this, that the sine of 30 is to its opposite side 7 as, and we're looking for side C, or excuse me, angle C, as the sine of C is to 10. So if we go about using law of sines here, then we have that 7, the sine of C is equal to 10, the sine of 30. If you remember your trig stuff from in the past, you know sine 30 is an exact value, also known as 0.5, but that's fine. We don't necessarily have to have that right now. Divide both sides by 7. And now inverse sine. I'm going to write it this way. So the inverse sine of all of this stuff, 10, the sine of 30 divided by 7. And so if we calculate this out, by the way, your calculators only give you one answer, but you need to know that there are two possible answers here. So if I calculate this out, I can type it in, by the way, just like that in your graphing calculator. You just have to use sets of parentheses, so be careful with that. This didn't like that, so I'm going to do a better job. Sorry about the delay here. You can speed through this if you want to. Okay, so we're going to end up taking the inverse sine of 0.714. I'll take this out to 2.8. Make that 2.9 if we round it. And we get 45.6 degrees. That is a little bit different. Oh, they used a little bit different situation in example 10. So, all right, so let's keep this. This ends up being, what did we get? 45.6 degrees. And so really what this is saying is that if you now take this 45.6 degrees, you could also have, you take 45.6 degrees away from 180, it also works and checks out. And so I'll show you that here in a second. But if we go 180 and we subtract off 45.6 degrees, we get 134.4. Okay, and so I'm going to show you how this would also work within the law of sines of having 134.4. Okay, so if we go back up here, we're going to put these values in. Let's put this in up here as this is the one that's going to be the 134.4. And this is going to be the 45, what was that, 0.6 degrees. All right, so let's assume we already know by the calculator it's going to be 45.6, but let's see if it checks out and put now 134.4 in for C right here and see if we get the same thing. So what I'm saying is if I take the sine of 30, and because we're rounding here, it's not going to be exact, guys. We should know that. But we got sine 30 over 7. Is that the same thing as the sine of 134.4 over 10? Okay, so if I go sine 30 over 7, I get 0.0714. And then if I go the sine of 134.4, and I divide that by 10, I also get 0.7014. It's a little bit different, but it is exactly the same in those first 4 decimals. It's different because, again, we rounded. So what does this say? This says that you need to be aware that in certain situations, and I encourage you to go read the example in the book. They take you through the investigation. But in certain situations, when we have an acute angle opposite the smaller of the two sides that were given, there could be, or there will be, 2 possible solutions there. Okay, that actually leads to a little corollary there on the bottom of page 488. I would encourage you to go look at it. It's kind of cool, but the sine of A is equal to the sine of B when A plus B equals 180 degrees. So there's that example for you. That problem set will probably have some situations, and that is problem set 11G. It'll have some situations where you're going to have to be aware that there is 2 possible solutions. Enjoy, guys. Work hard, and we will see you later. Have a good day.